This is going to be a short video about understanding hexadecimal. To understand hex, let's first understand how we count. We count in a base 10 numbering system. So this spot, let's say we have a 2-digit numbering system. This is the 1 spot. This is the 10 spot. And this is great because we have 10 fingers on our hands. So it makes really easy to count in base 10. We take this number times 10 plus this number times 1. Now in base 16, which is hex is base 16, we count with a 16 spot, 16 spot, and a 1 spot. Now Colton, we only have 10 numbers. How are we going to do this? Well, right now we have 10 numbers in base 10. How we usually count, we have 1, we have 2, we have 3, we have 4, we have 5, 6, and 9. And actually, I forgot one. We have 0. 0 is really important. If we count in base 16, we need to have more than that. So we'll add on some letters. We'll have 0, 1, 2, and then we'll have 9, and then we'll have A, and then we'll have B, C. So there's only D in there. So we'll say D, E, and F. So 0, 1, 2, up to 9, they all represent 0 to 9. That's going to stay the same, very simple. A is going to be the same thing as base 10 in base 10. B is 11, C is 12, 13, 14, 15. So when you see a base 16 or a hexadecimal number, know that the number here, let's say this is a 0, just make it easy, and this is a C, that is 12 in hexadecimal. If we see a number like, let's say 10, excuse me, that was silly. If we see a number like A, 0, A is 10, times 16 is 160, and then 0, so don't add anything onto it. So that is 160 in base 10. If we have something like, let's say FF, that is 255. And that's the biggest you can go. Over here, the biggest you can go is 99 in the 2-digit number. Down here, the biggest you can go is FF, which is 15 times 16 plus 15. The smallest you can go is 0, 0, so that equals 0. So you can go all the way from 255 to 0. So that means you have 256 possibilities. And what's neat about this is that that fits into a binary system. So here we have 16 is a 4-digit system in binary. So we have 1, 2, 3, 4. We have 1, 2, 3, 4. So this is 1, this is 2, this is 4, this is 8, this is 1, this is 2, this is 4, this is 8. So if we were to write, let's pick a funner one than that. Let's do A. We can do A. So A is 10. So there's 1, 8. We'll do A5. We have which an A5, 10 times 16, 160, plus 5 is 165. But the computer doesn't store that as A5. It doesn't store it as 165. It stores it in binary bits, which is written out in base 2. So 1, 2, 4, 8. And here it is stored as A, remember, is 10. So we have 1, 8 in there. Subtract 8, we have 1, 2. So that's a 0. That's a 0 with an interest of 5. We don't have an 8. We can subtract a 4. That leaves us with 1. So not a 2, but a 1. So I have 1, 0, 1, 0, 0, 1, 0, 1. And that is A5. So this is why we use hexadecimal, but we don't need to go down to that level. We can store numbers and think of numbers in hexadecimal, where we have things like A0, FF, 1C. So 1C is 16 plus 12, which would be 28. And it's a nice compact way to write and read numbers. So this is how your computer is thinking, and then brings that down to this level. And the reason that in these lessons we have 0x is just to show that is a hexadecimal number. So we can show 0, meaning this can be a number, x, meaning that it's a hexadecimal number. We use x because it's outside the range of 0 to f. And then after that is the actual number portion. So then we can have 0xff. So up here, that'd be the same thing. We'd have 0x, 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 0x. Another way you can write this is to put a h afterwards. So we can say, and again, h is outside of this realm, so it's not like it's going to add on to it. We couldn't use e because it's going to look like we're adding 14 on. So we could say 1ch. 1c, that's 28, because it's in hexadecimal.